Hey folks, 12.5 here. Last video of the unit. We're going to kind of tie things together here using our double angle formulas and solving equations. The first question is a little bit more difficult. It involves the sum and difference angle formulas, so I'm going to actually come back to that one. I'm going to actually start with question number 4, so go ahead and turn to number 4. All right, so in number 4 it says solve 2 secant squared x plus tangent squared x minus 3 equals 0. We can't put these two functions, this is not the same as like 2x squared plus x squared, okay? Those are two different functions. So what we're going to do is we're going to look to try and put them in terms of sine and cosine, just as we would if we were simplifying. So I can change 2 secant squared x, because secant squared, remember, is one of your reciprocal functions, so that's equal to 1 over cosine squared x. So I'm going to change this into 2 over cosine squared x. And tangent squared, remember, is sine squared over cosine squared. So we can go ahead and replace that one. Oh, look at that. Common denominators. That's helpful. Okay. So there we go. Only problem being the little 3 that we have over here doesn't have a common denominator. So in order to help us out here, what I'm going to do is, since these two, the first two fractions do have a common denominator, I'm going to put them together as one fraction. So I can rewrite this as 2 plus sine squared x all over cosine squared x minus 3 over 1. All right, I'm going to work a little magic here. I'm going to add 3 to both sides. And the reason that I am doing that is I now have a nice little, oh yes, proportion. Okay, so by adding that 3 to the other side, I created a proportion. And how do we solve proportions? All right, we cross multiply. So I am now going to take this and cross multiply, and if I cross multiply times 1, isn't going to change anything. So 2 plus sine squared x is equal to, cross multiply the other way, we get 3 cosine squared x. Now we started out with 2 different functions at the beginning of the question, and I got to a point where I still have 2 different functions, but what I can do is I can replace my sine squared with 1 minus cosine squared x. That's one of my Pythagorean identities. All right, so what I have now is I have 2 plus 1 minus cosine squared x equals 3 times cosine squared x. Now, some of you may be asking right now, well, Mrs. Croft, how come you didn't change the cosine squared x into 1 minus sine squared x? And you could have also done that also. So it's not going to matter. You could replace either one of them as long as everything is either sine or everything is cosine. So you could have done that. That's also another option. So over here we have, I'm going to take, this is going to give me 3 when I add those together. But because I have these squareds, I want to take and move everything over and set it equal to 0. So we're now going to, I'm going to subtract 3. I'm going to add the cosine squared. I'm going to end up with 0 equals. Now, if I add a cosine squared over here, I get 4 cosine squared. And I end up with my 3 over here. So that's going to be minus 3. Whoops, minus 3. Okay, so let's take that equation back up here a little bit. 4 cosine squared x minus 3 equals 0. All right, I'm going to set this, I'm going to solve for my cosine value. So I'm going to add 3, so kind of back to where I started from, but that's okay. And then I'm going to divide by 4. So I now have cosine squared x equals 3/4. Now, how do I undo a squared? Good, we're going to square root that. All right, so I now have the cosine of x is equal to, don't forget your plus or minus, radical 3 over 2. Oh, radical 3 over 2. I think I have heard of that value before. So when I go to do my inverse cosine, I'm going to do positive radical 3 over 2 first. So let's think about this for a minute. Whose angle has a cosine value of radical 3 over 2? Yeah, good job, 30. Okay, so 30 degrees. Now, because of the plus or minus, that means I need answers from all four quadrants. So I'm going to use that 30 degrees as a reference angle in all four of my quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4 are all going to have 30-degree reference angles. So from quadrant 1, we get an answer of 30 degrees. Quadrant 2, if I have a reference angle of 30 degrees, what's my answer going to be? Good, 150. All right, we move into quadrant 3. Remember that's 180 plus 30. Yep, 210. And quadrant 4 is going to get an answer of, yep, you subtract 30, 360 minus, good, 330 degrees. And those are your four answers on that one. Okay, so just to recap that question, when we started out, we simplified everything in terms of sine and cosine. And then as we moved down through the question, we used one of our Pythagorean identities. Okay. All right, I'm going to skip to question 6. So turn to question 6. It says, what is the solution in terms of pi? So that means you're going to have your answers in radians of the equation 2 sine theta minus cosine squared theta plus 1 equals sine squared theta plus sine theta in the interval from 0 to 2 pi. All right, there's a lot of substituting that's going to go on in here. So first thing I'm going to start with is my double angle sine of 2 theta. And if you want to, you can change your thetas to x's. It doesn't matter. I don't mind my theta. So this is going to be 2 sine theta cosine theta. So that was our first substitution. That was a double angle formula. Now I'm going to leave my cosine squared for now. I may have to change it later, but I'm going to leave it like that for now. Plus 1 equals. All right, and we have sine squared plus sine. Now, if you'll notice, everything so far, I have some cosine values over here. I'm going to take a chance and substitute out this sine squared. So I'm going to take sine squared and I'm going to do one of my Pythagorean identities, 1 minus cosine squared. Now, here's why I just did that. Because if you'll notice, what's going to happen is if I add a cosine squared to both sides of my equation, what happens to my cosine terms, cosine squared terms? All right, they end up canceling out. So that's one of the reasons that I did that, was so that I could get rid of some terms there. All right, there's another thing that you would be able to cancel out. Anybody see what that is? Yeah, if you go ahead and subtract 1 from each side, that also gets rid of those two values. So you just knocked out a couple terms just by doing some substituting and some inverse operations. All right, so I'm just going to rewrite what we have here. We have 2 sine theta cosine theta equals the sine of theta. I'm going to set this equal to 0, so we're going to subtract over our sine theta term. Now remember, just as you can factor, as you can use inverse operations, you can also take out a GCF. So if you'll notice in this question, we have a GCF of the sine of theta. So I'm going to take out the sine of theta. That's going to leave me with 2 cosine theta minus 1. Now it's okay that I have two different functions here because I can set the sine of theta equal to 0. And I can also set 2 cosine theta minus 1 equal to 0. So coming up here to the top here, if I take sine theta equals 0, we'll deal with that one first. I'm going to do the inverse of sine of 0. All right, remember when you have 0, 1, or negative 1, we use our major points on our unit circle. So I'm just going to put those major points on there to remind me what I'm working with. So inverse sine of 0. So whose angle has a sine value of 0? And as I go around my circle, like I know there's one of them, because that would be the point 1, 0. That would have a sine of 0. And that's also going to happen over here at 180 degrees, because that's negative 1, 0. So this first side here that we're working with, that has two different answers. It has 0 degrees and it has 180 degrees. I'll deal with putting the answers in terms of radians in just a minute. Let's get all of our degree values first, though. The other equation we were working with is 2 cosine theta minus 1 equals 0. So I'm going to add 1, divide by 2. I'm going to end up with the cosine of theta is equal to 1/2. All right, so whose angle has a cosine value of 1/2? Yeah, 60 degrees. Okay, so 60 degrees. Now think about this. This is a positive number. Where else is cosine positive? Right, in the fourth quadrant. So you're going to use that 60 degrees as a reference angle in the fourth quadrant. That's going to get you another angle. That's going to get you an angle of 300 degrees. All right, so we went through, we solved for theta. So these are the degree values. If the question asks us to give an answer between 0 and 360, we would be done. But it asks us from 0 to 2 pi. So what we want to do is we want to convert all of these to radians. So 0 degrees is just 0 radians. Let's see, 60 degrees, if you remember a little review here, convert to radians, multiply by pi over 180. Okay, that's going to reduce. That's going to give you pi over 3. So the next one would be pi over 3. All right, 180 is the next biggest value. That's just pi. And then 300, if I multiply that by pi over 180 and reduce it, I end up with 5 pi over 3. And that is my radian value. So you always want to check to make sure that you're answering, should you be answering in radians or degrees? It's one thing they'll try and ask you on the Regents exam. They can ask either one. All right, so that's just a couple examples of walking through using your double angles and your Pythagorean identities when you're solving equations. I decided while I was doing this video that I would save number 1 for class since it is pretty difficult. And I want to make sure that you guys understand when we're substituting and using the sum and difference formulas. So in class, we'll do a couple examples together, and then I'll have some group work for you guys to do, practicing more solving equations. I hope you guys have a great day. Thanks.